All right. The first section we're going to talk about is intro to graphing. What is a graph? What is a graph? What's the purpose of a graph? Not data. Okay, you call it data because data is what you're looking for information. It's true. That is what it's used in the real world of business. But basically what it does, it is a visual representation of a function, of the behavior of the data. So let's begin. What is a point? We know when we graph something, we put a dot, a point. What is a point? Yes, but how do we find a point? I'm glad you said the location. And individual data point. Yeah, it's true. When we talk about functions, we haven't talked about functions. We can't use terms unless we have them defined. Since you use function, then you have to define a function. So we haven't done that yet. So a point is a location. In another name instead of location we use it's called a coordinate. If you ever look at a map, how many of you ever looked at a map? Because you'd be surprised how many people under my age have never seen a map because they have everything on Google Waze and stuff like that. So let's look how this stuff started. In the beginning, we had a straight line. If you think about it, in elementary school, what numbers do you first talk about? Numbers on a number line. You have a beginning, and then you start going to the right, all the way to infinity. Okay, these are the what are these numbers called? 1, 2, 3, 4, 5. What are those called? They are those, but that's not what they're called. These are not points yet. These are the numbers. It's the numbers. It's only the positive integers. What are those called? Natural numbers. Very good said that. Very good. Yes. Natural numbers are 1, 2, 3, and so on and so forth. The reason they're called natural numbers, or another name for them are counting numbers, is because whenever somebody asks you to count, you always start at 1. So these things start at 1, go to infinity. Well, then why do we invent 0? Because that was, out of all mathematics, that was one of the most difficult concepts to come up with. How would you define 0? Nothing. Okay, define nothing. What do I have in my hand? And how can you prove it? So, no, so this is the philosophical thing. This is
just by looking at it.
Yes, but now remember, think back when math first started in the 4th, 5th, 6th centuries, when it all started because of commerce. People had to figure out, okay, they should be just a communal society where everybody, if you need some food, I give you some food. But then it said, well, it's not fair. You're taking all my chickens and cows and pigs. You're giving me nothing back in return. So that's just start looking at commerce. 0 is the beginning. Because if you're going to start, if we're come up here, you have nothing and I have nothing. We have nothing different. So now we start changing. I will give you 3 chickens. That's worth 1 pig. So that now you have a way to quantify what you're dealing with. So eventually, now also another interesting thing here is this all started in the Middle East. If you know anything about the Middle East, how do they read their text? Right to left. How do we count? Yeah, what happened? But yes. Well, yeah, like the Japanese, they still the top down, left, right. So yeah, there are a lot of countries that still do that. And my question is why do everybody change from there? Is somebody else been dyslexic and changed it? But anyway, after natural numbers, those are all these. Then we introduce zero. That looks like a hole. So we call those whole numbers. Whole numbers start with a hole. Well, again, since we're dealing with commerce, eventually somebody spends more than they have, and we introduce negative numbers. What are those called? Integers. Very good. That's everything from negative infinity to zero to positive infinity. Now, somebody said earlier, rational numbers. Those are rational numbers. Rational numbers mean what? Those would be decimals. But you're right. That's where they come from. What is the first 5 letters? What does that spell? What does ratio look like? But yeah, then we could look at it this way, and A is to B, A to B. So this we're saying every number is a rational number, except for the irrational numbers, like pi. In other words, every number except the irrational numbers, again, I'll tell you the difference in a second, can be represented as a fraction of something. In other words, these are rational numbers because they're all divided by 1. Everything's divided by 1. Irrational number actually there's a more mathematical definition for a rational number. Mathematicians are not too creative. Numbers that are not rational. That's how they defined it. You look at textbooks, you'll say that an irrational number is a number that's not rational. The difference, a rational number is either a terminating decimals. In other words, something like 2.451. It stops. There's no more decimals after that. Or it's repeating. 3.141414. That's, you see the pattern is now repeating. Those are rational numbers. If both of those conditions do not exist, then it's an irrational number, like pi or E, Euler's number, which we'll talk about later on in this course. It's a rational number because we can predict the next set of numbers. And the way we do these, if they're repeating, we would simply write where it starts repeating and we put a bar over it, because it tells us that these two numbers are repeating forever and ever.
It doesn't terminate. It does go on forever.
And we don't know what the next number is. Well, we do know but there's always one after that. We don't know. We don't know. Well, we've gotten to like the billionth, trillionth decimal place, and they're still calculating. So, and you wonder why. Okay, we realize that, but somebody wants to realize that eventually, after some quadrillionth, billionth, zillionth number, it starts repeating itself. But then the only way you can prove that is if you repeat it to the next, and you can start the program now and run it for the rest of your life, and you'll never get to the end of pi. And they've done that. They've had supercomputers running for decades that still can't reach the end of it. So those are the numbers. And then we all started this in elementary school. We started learning this in pre-K and kindergarten and first grade and going from there. But then somebody realized, and if you think about it, how did humans travel at the beginning? Walking, riding a bicycle, riding a wagon, riding a horse, running from dinosaurs. I mean, all this stuff. It was all horizontal. But then eventually we started going up and down. Airplanes, balloons started going up, submarines started going down. So we do the same thing. So, but it all starts from nothing. Going up is positive, going down is negative. Now, since we have two axes, these are called axes. This is the y-axis, and this is called the x-axis. But that wasn't called that originally. The abscissa and the ordinate. That's where the word coordinate come from. They go together. A coordinate is a location, a specific location, a pair of numbers. Since the horizontal came first, it goes first, then the vertical. Now, the story behind this is super interesting as well. It was invented by a guy named Blaise Pascal. No, Rene Descartes. I'm sorry, no, Blaise Pascal did another one. But Rene Descartes, the guy who said the word, I think, therefore I am. He was sick. He was in his bed and he saw a spider crawling on the ceiling. He goes, from the corner of my room, I could tell you exactly where that spider is. Go down 5 lines and then go over 4 lines. And he invented the coordinate system. Remember, that was Rene Descartes. Okay, now this is another thing. What do we call this graph? It has to do with his name, Cartes. This is called the Cartesian coordinate system. Again, mathematicians are not too creative in their names. He invented it, so he's going to call it Cartesian. And it's a coordinate because there's 2 numbers, and it's a system, which means that it has rules. So now in the Cartesian coordinate system, to the right is positive, to the left is negative, down is negative, up is positive. Actually, let me go to, if you ever see a military movie and you hear them, when you hear them says, I read you 5 by 5. What they're doing, they have a screen that has 5 degrees, both top and bottom, left and right. That's the radar. That's exactly what's all they could see. And if the signal comes in within that, then it's to read them 5 by 5.
What scale, loud and clear, so the x-axis is loud and clear. Does that know what that means?
Loud and yes, because when a lot of times you see these sinusoidal waves, you see like these in science movies, and that's all that does is it records the sound coming in. As if it's loud and clear, this is the definite, distinct pattern where you have the amplitude and you have the degree, the period. So now when the cards do this, we have to call that middle point something. We'll figure out in a second. But he said, okay, let's look at this point here. Oops, not that point there, that's off the line. Let's say I'm at 2 here. My spider is here. So what is that spider's coordinate? It's 2 on the x-axis and 3 on the y-axis. That's its location. Because remember, x goes before y. X is horizontal, y is vertical. How about this bug? -2, +1. This one?
-3, -4.
-3, -4, and then this one.
2 and -4.
Okay, now is to make it easier for everybody to tell me, so what quadrant are you? So there are 4 corners here. Those are called quadrants. Because there are 4 quadrants, we have to be able to distinguish which quadrant are we talking about. So we start up here. This is quadrant 1,
2,
quadrant 2,
3.
and then quadrant, and it's always written in Latin numbers, in Roman numeral. Okay, here's a question I have. Another interesting question to y'all. Why is it that way? Would we have labeled them like this today?
I would imagine since, Marx created this, that he labeled it that way because that is his language.
No, he used those numbers for his language, but why backwards? Why is that backwards? Is it clockwise? Everything we talk about now is usually clockwise. If you look at everything we divide design nowadays, it's clockwise, even the clock. How's that?
Right.
Oh, no. Because this is in Europe. They already started reading left to right a long time ago. But it does have to do with time. Remember, I told you that math started many, many, many years before that. Did they have clocks back then? What do they have? The sun rises in the east and sets in the west, and the moon follows. So that's the reason they went counterclockwise, because them that was their clock. What do we call the center point here? The origin. The origin is the location of 0 before anything happens. And that's where you start with everything. That's the origin. That's the beginning. If we go to this point, we start from 0, 0. We go 2 to the right since it's positive and up 3. This one, we start here. Go 2 to the left since it's negative and up 1. So with that, we see that any numbers that are both positive are in quadrant 1. If it's negative, then positive, it's in quadrant 2 because we go left, then up. If they're both negative, we go left, then down, we're in quadrant 3. And then positive and negative go to the right and down, we're in quadrant 4. So it makes it easier for us to help us to graph where we're looking at. So far, so good. Now, we've laid the basis, the groundwork for these things. Now we got to go into algebra. One, two. I only use the first quadrant, make it easier for us. I'll give you the first point. Can we define the equation of a line going through that point? How many lines can go through that point? 1, 2, 3, 4. Infinite number of lines. What do you need to have in order to define a line? A specific line. We can't do it with 1 point. What do we need? We need 2 points. Because once you have 2 points, the line is now fixed. One and only one line can go through those 2 points. That's the definition of a line. Definition of a line is it goes infinitely in both directions. What do we call if it has a starting point and goes on infinitely? What is that called? And you'll see why they call this because we have the sun and it has these things that, what do they do when they come out? These, when people draw these things, what are these called? Rays. They're rays of light. That's what this is called. If it has one starting point and it goes a direction, that's called a ray. In other words, a ray has a starting point and it goes to one direction. If it goes in both directions, it's called a line. What if it has a start and a stopping point? What is that called? Very good. Good guess. A line segment. Which is the argument I have with the NFL. When they say they're on the 45-yard line, that's not a yard line, it's a line segment. Because it starts and stops on both sides of the field. But they don't answer my messages. So now, what to find the equation of a line? What do we need? You need 2 points. But then the first thing you do with those 2 points is what we really need is 1 point, that's the starting point, and we need the slope of that line. So one of the equations we're going to figure out is the equation of a slope. What else can we find if we have 2 points? What information can we find about this line? Here we talk about slope. Okay, the x-intercept and y-intercept. What do those represent?
They represent where they cross the X.
Very good. Yes.
Same thing with the y-intercept.
Where the line crosses the x-axis and where the line crosses the y-axis. So the x-intercept is where the line crosses the x-axis. It intercepts the x-axis. The y-intercept is where it crosses the y-axis. We'll talk about those in a second. What else?
Somebody's rise and run is also one of them.
That's slope. Oh, yes. Domain and range. What's the difference? Easiest way to think about it is, you know how our points are labeled X and Y? Same thing with the domain range. Because X comes before Y, D comes before R. The domain are all X values possible. R is for range. That's all Y values possible. That's what, whenever we talk about domain, we talk about what X values can we use? Range, what Y values can we have?
Is that in relation to the line that's drawn, or is that just in general?
Ah, good question. It's in both. Because in general, it references not just a line, it's any graph and any representation of the data points. It's what's the lowest, what's the largest, what's the highest and lowest it can go. But in this case, we're using only lines so far. What else can we talk about? Two more distinct things that we can talk about. Remember, since we have 2 points, we have point A and point B, or we call them point 1 and point 2. Let me go a little bit further on this when we label things. This is our first point. Why is this point 1? In this case, yes. But typically we do with respect to, it's the closest to the origin, yes. So no matter where it is, yes, that's what we do. It's what number comes in first as we go left to right, or and if you go to the opposite, left. So it's made up of an X and Y component, right? So it's to differentiate the two, it's made up of the point X1, Y1. The subscript tells you what point it relates to. So this one is X2, Y2. We have to be able to distinguish the coordinate points themselves. Because if I just said XY, XY, you wouldn't know what I'm talking about. So I have to say X sub 1 or X sub 2. Which one do we need? So since we have 2 points, we can figure out the distance between these 2 points. So we can find the distance between those 2 points. And the last thing, since we have 2 points, we can find what value is halfway. It's called the midpoint. It's a point, it's a location on that line. So these are all the equations we're going to talk about today. So let's get started. Okay. The intercepts, we can't do anything right now with them because you find the intercepts once you have the equation of the line. The domain and the range, well, with lines, it's pretty straightforward. It's easy. It's always all numbers, infinity. And we'll look at distance, midpoint, and slope today. Let's begin talking about slope. What is a slope? Okay, we can't use angles because it's not trigonometry. The slope is the relation of, let's see, of any 2 points on a graph. There's a slope. If it's a line, it's constant. It means each point well, as first, how would you define slope in words? Because I'm saying it's a relation. You said it earlier.
Oh, rise and run.
Rise over run. That definition is what we typically teach our elementary school kids, but it's not really accurate. Because rise means from this point, I go up, let's say 2, and then over 3. So that one would be up 2 over 3. And the bottom is always positive. In mathematics, if you have a number like this, either move that negative out in front of the whole thing, or it goes with the top. It always goes to the top, because if we're doing addition, subtraction of fractions, you never subtract the denominators. For example, if we had 4 minus 7, how would you do that? Well, since you have a common denominator, you have that sign has to go with the top. So it will be -3 over 9, which is -1/3. So whenever you have negatives, that always goes with the top number. Negatives never go with the bottom number. But you're right. So in other words, what I always like to do is it's either rise or sink. If it goes up from this point to this point, going left to right, if it goes up, then it's rise. If it goes down, then we're dropping. That's a negative slope. So if it's positive, it's a rise from this point to this point, if it's a positive. If it's a negative number, it goes from here, it goes down. And the bottom number is always positive, always goes to the right. So far, so good. Now let's go from these words to math. In mathematics, to represent the slope, we have to use a variable, a letter. So we use M. Now, what does rise mean? How would you know if it's rising? Right? It's the change of Y values. And the run is
That sounds.
the change of your X values. So what does all this mean? What is change? Whenever you see the word change in mathematics, we use the delta symbol. So it's the change of Y over the change of X. Change is the same thing as difference. What's the difference? Or how far is it from 3 to 7? How'd you get 4? Okay, how about this? How about from 2 to 85? How about from 10 to 137? How'd you get those numbers?
Subtract the second number from the first.
Very good. So if I had x1 to x2, it's always going from smaller to larger. What you just did was x2 minus x1. So it's 7 minus 3. These are my x1 numbers. These are my x2 numbers. 85 minus 2 is 83. Yes. So the change of x is x2 minus x1. What's the change of y? There's your formula for the slope.
So does that mean, where y point is 3, then it would be, 1, 3?
Well, yeah, we'll go back to the graph we just had. No, 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 no. It's you're thinking ahead, which is fabulous. So this is the graph we had in the last page. What's the location of point 1? 1, 1. Location of point 2, it's 4, 5, yes. So whenever we do anything with slope equations of lines, we have to label the points. So we have point 1 equals x1, y1. Point 2 equals x2, y2. Then label the coordinates. So what does that mean is you have to define what x1 is, what x2 is, what y1 is, what y2 is. This is going to save you so much time and decrease the number of mistakes you make. So in our example, what is x1? Yeah, it's the x value of 0.1. The x value of 0.1 is 1. What's x2? 4. It's the x value of the second point. Y1 and y2. Again, these subscripts tell us what point it belongs to. So y2 is the y component. This is x and this is y. The y value of 0.2 is 5. x2. The x value of 0.2. The x value of 0.2 is 4. Now we could find the slope. y2 minus y1, x2 minus x1. Just refer back to what we just had. What is y2? 5. Minus y1, x2 minus x1. Yes, there is your slope. Do not put them in decimals. A decimal slope really means nothing to me. This, if I look at this number here, I can tell you the relationship of each number. From one number to the next, I go up 4 and to the right 3. Up 4 over 3, up 4 over 3, up 4 over 3. All the points of the graph have that relationship. So far, so good. All right, I'm going to give you 2 points. Find me the slope here. Find me the slope of those 2 points. I don't know yet. I have to work it out. And you don't need a calculator. Do not use calculators. So the way you solve this is first, always put down, since you're looking for the slope, put down the formula of the slope first. Second, label the points, x1, x2, y1, y2. So this is my first point. This is my second point. So that's x1, y1, x2, y2. So x1 is -3. Y1 is -5. X2 is 7. And Y2 is 1. It sounds trivial, but I guarantee you the most common mistake I see on students' exams, if they just go right from these, what they're going to do is x1, x2, y1, y2. I've seen it 1,000 times. So if you label like this, all you have to do now is just plug and play. Y2 is 1 minus -5. 7 minus -3. Two negatives next to each other becomes a positive. So we have 1 plus 5, 7 plus 3, 6/10. Is that my answer?
Can you reduce these?
Can you or must you? Yes, you must. Whenever you can reduce, reduce. Because it's going to give us the same thing. Yeah, but 6 is made up of 3 times 2, 5 times 2. The 2's cancel, so it's 3/5. So it tells me that from every point, I go up 3/5, up 3/5. The next thing we're going to talk about. Okay, we did the slope. Do you want to do distance or midpoint? Let's do distance because it'll keep us in the same realm. Distance. Do you know any formula that deals with distance? Have you ever heard of this one? That is a distance formula. If you think about it, you've seen it before. Let's I'll make this A, B, and make that C. In trigonometry, because this is geometry, the capital letters represent the points. And little letters represent the lengths. So the length from C to A is that little distance B, because it's opposite of where that angle is. Here's angle A, so that's A. So what does this represent? What this thing says is the square of this distance plus the square of this distance equals the square of that distance. What's this distance called here?
C.
Hypotenuse. I ran out of space. It's the hypotenuse. And these two are called legs. So far, so good. Now, how does that relate to our picture here? How does that relate to our picture here?
By drawing that line, are you creating a new hypotenuse so we can figure out?
Because we're looking for the distance between point from A to B. We're looking for, this is going to be the C line. The hypotenuse equals the distance from A to B. The hypotenuse is the distance from point A to point B. It's the shortest distance. So you see how this picture can fit on this? So from A, I could draw a horizontal line. And then a vertical line from B. I've created my triangle, where this is little a, this is little b, and that's C. It only works on right triangles. They're 90-degree angles. So far, so good. So the question is, how long is B? How long is A? Because we need to know those to use our formula. Not 4 squared by 4 squared. Basically, we're looking at from this point to this point. How far is that?
3.
How'd you get that? We're starting from here, going to here. Remember what we did earlier, the delta, the change? The horizontal change is from 1 to 4, so it's 4 minus 1 is 3. So we do the x2 minus x1, we get 3. So that is what B is equal to.
Right.
Do the same thing for A. We're stopping at 5, we're starting at 1. We're from 1 to 5. So from 1 to 5, we go 5 minus 1 is 4. So A, this equals A is 4. Nope. Now, remember order of operations. Exponents or addition, which one do you do first? Exponents, special operations. So 4 squared means what?
16.
4 times 4 is 16. 3 squared is 3 times 3. 16 plus 9 is 25. So what two numbers multiply to give you C?
5.
5 times 5. Or another way we could do it, to get rid of the square, if we square root both sides. So that's the distance between A and B. That's how the distance formula works. If I lose you, please, please, please stop me and tell me to repeat it and fix it. Because now I'm going to let you guys do the original example we did. So find the distance between our 2 points from our example. -3, -5, and 7, 1. Hold on, I never gave you the actual formula. I'm sorry, my bad. We know that since we're looking for the distance. We're using the a squared plus b squared equals c squared. A squared was, for giggles and grin, that's the distance, let's say horizontal distance, this is the first letter. So we have x2 minus x1 squared. B is going to be the vertical distance, y2 minus y1 squared equals, since C is a hypotenuse, it's the distance, there's a formula. Remember, C, the hypotenuse was the distance from A to B, from this point to that point. And what do we do to get D by itself, or get C by itself? How do we get rid of that square? We square root it. So if we have D, then we take the square root of all that stuff. So those are your formulas. And we'll talk about radicals, the square roots, in a second as well. So find me the distance, please. Okay, let's look at this. So the first thing you're supposed to do is label your points. What's x1? -3. What's -5? Is the y1. And 7 goes to, and then 1. Right. Once you have that, it's a matter of plug and play. So the distance equals x2, 7 minus -3 squared, plus y2, 1 minus -5 squared, order of operations, we have to do inside the parentheses first. So there are two negatives here. It becomes 7 plus 3 squared, and then 1 plus 5 squared. Seven plus 3 is 10. 1 plus 5 is 6. So far, so good? 10 squared is 10 times 10, which is 100. 6 squared, 6 times 6.
36.
100 plus 36. Okay, hopefully everybody got to that point. Now, here's the thing about square roots. We know, like, square root of 16 is what? Why is it 4? Because 16 is made up of 4 times 4. We have 2 of a kind. So anytime you have 2 of a kind, you can take outside the radical. Let's look at square root of 8. What is 8 made up of?
2 times
2 times 4. Okay, 2's, you can't go any further. What is 4 made up of?
2 times 2.
So 8 is made up of 2 times 2 times 2. We have 2 of a kind, so it can come out in front. This one stays inside there. So we do the same thing with 136. What is 136 made up of? Since it ends in an even number, we know it's divisible by what number? We know that 2 because it ends in an even number. 2 goes into 13 how many times? 6, with 1 left over. 2 goes into 16 how many times? So there's one number. 68. It's divisible by 2. 2 goes into 6 how many times? 2 goes into 8. 34 ends in a 4. So 2 goes into 3 how many times? With 1 left over. So 2 goes into 14. So we have 136 is 2 times 2 times 2 times 17. That's called prime factorization. Next time, if I remember, I'll give you a sheet, have all the rules of divisibility. How do we know that number one divisible is divisible by another? So according to the rules, since it's a square root, if we see 2 of a kind, they come out in front. Since these can't go any further, we multiply them. 2 times 17. So there's your simplified answer. Break it down to its smallest pieces, prime factorization, and then see if you can see 2 of a kind, and then take those out. But I think it'll take this as well. If you enter that and it says simplify, then you know you have to go a little bit further. Any questions? So that's the distance formula. Yes.
I know we talked about it on Monday very briefly, but can you please define radical again for me?
You define it? Yes. This is called an nth root radical. This number inside here is called the root. The root tells us the number of times a value must be repeated to remove it. From inside the radical. So if we have a cube root of 16, that means we're looking for 3 of a kind, of this 3 of the same number. So 16, we break it down to 2 times 8, 2 times 4, 2 times 2. 2 times 2 times 2 times 2. We need 3 of a kind. No, it's just bring out the 2. Since it repeats itself 3 times, it's 2. Besides, it'll be 8. 2 times 2 times 2. So yeah, since it repeats itself 3 times, it comes out. Anything else stays inside there.
Thank you very much.
Yeah, so if it's like that, there's an invisible two. That's why we say square root, showing two sides. Okay, we did distance, we did slope. Let's look at midpoint. So here's point A and point B. I want to know what is the location of that point halfway between point A and point B. Remember, it's a midpoint. It's a point, which means it has to have an X and Y component. Unlike the slope, this is little m, the midpoint is capital M. So far, so good. Look at two different ways. Let's look at the X components and the Y components. So from 1 to 4, what number is halfway between 1 and 4? Another way to think about this. Let's say you had 2 exam grades. What's your average? How would you find the average? Adding them together, divide by 2. So to find the number that's halfway between here, the average, I would take 1 plus 4 and divide by 2, which is 2 and 1/2, which is right there. So that's the X component of that midpoint, 2 and 1/2, 2.5. Same thing on the vertical. 1 plus 5 divided by 2, so it's 6 divided by 2 equals 3. So the midpoint is, you could put 5 over 2 and 3. You could put 2.53. You could put, bless you, 2 and 1/2. Any of those work. So now we have to figure out what formula do we put there? X1 plus X2, because we're looking for the average of your X's and the average of your Y's. So far, so good. Again, you see the importance now of labeling your points first. So in here, my point 1A was at 1, 1. Point B was at 4, 5. So I labeled X1, X2, Y1, Y2. You have to do that anyway for the slope and for the distance and everything else. Once you define it, it's now just plug and play. So let's look at our example points, which were -3, -5, 7, 1. Find the midpoint. the equation is x1 plus x2, y1 plus y2 over 2. Always start by putting another formula down. Then label our points. We have -3, 7, -5, 1. We have -3 plus 7, -5 plus 1. All right. This is another place where a lot of students make mistakes with negative signs. That's gonna be the kiss of death for y'all. So here are the rules of subtraction and addition. If the signs are the same, then take the common sign and add the numbers. If the signs are the same, take the common sign and add the numbers. Okay, finishes that. For example, 3 plus 5. They're both positive, so the answer is going to be what? Positive or negative?
Positive.
And then we just add 3 plus 5 is 8. -4 minus 7. They're both negative, so the answer is going to be what? Negative. 7 plus 4 is
-11.
11. That's that rule. Always treat your signs and numbers separately. The errors happen when you try to do them both at the same time, you'll get confused. So that's the first rule. The second, if the signs are different, then take the sign of the larger number and subtract large minus small. Because a lot of students have been so conditioned to use calculator, these basic rules slip aside. 9 minus 4. Is the answer going to be positive or negative?
Positive.
Why positive?
9.
9's bigger than 4. It's positive, so the answer is positive. So 9 minus 4 is
5.
-2 plus 7.
5.
7 is bigger than 2. It's positive. Answer is positive. So 7 minus 2 is 5. Yeah, 8 is bigger than 1. It's negative. Answer is negative. 8 minus 1. They're both negative. This is a trick question. They're both negative, so the answer is negative. 4 plus 3 is 7. Okay, use your calculator to check your answers, not to do the work for you. It's supposed to, as I said, it's supposed to supplement your education, not replace it. So back to our questions. -3 plus 7. Positive or negative?
Positive.
7 minus 3.
Four.
-5 plus 1.
Negative.
It's going to be negative. 5 minus 1 is 4. Now, is the first one going to be positive or negative? Positive. 4 divided by 2. The second one will be positive or negative?
Negative.
4 divided by 2.
Negative.
Right. Treat the signs separate than the numbers. If you do that, the chance of making a sign error on your calculations are going to go down to 0 pretty much. So there's midpoint. We did the distance, we did midpoint, we did slope. All right. We talked about points. Another way we can do points is check if a point is on the graph of an equation. So here's the equation. There's a point. Is this point going to be on the graph of this line? Is this function, the equation? Ah, that's not mathematic. It's either yes or no. How do we check it? Yeah, we know this is the point. This is the X and this is the Y. Plug them in there. So what's my X value? What's my Y value? 4 times 2 is 3 times 1. 8 plus 3 is. So no, it's not part of that graph. Just plug it in there, see if it works. All right, the same equation. Find me the Y value that makes that equation true. Okay, so what do we know about so far? We know we have to use this equation. We know what X is. We have to find Y. So let's begin. What do we do first? Yeah, we can't do anything inside the parentheses, so we multiply, get rid of the parentheses. Positive times negative. Negative, 4 times 3. We're solving for Y. We have to get that by itself. What do we have to get rid of? The 12, the negative 12, because it doesn't have anything. So we have to move this number. How do we move it to the other side? Do the opposite, exactly. Since it's negative, we have to add 12. It's a process of opposites. Positive 12 and negative 12 cancel each other out. 9 plus 12 is? Now I want to get Y by itself. How is 3 connected to Y? Is it added, subtracted, multiplied, or divided?
Divide.
It's multiplied. So yeah, we do the opposite. Opposite of multiplication, division. So we divide both sides by 3. So the point -3, 7 is on the graph. We'll do tons of these, so don't worry about it if you're not. I'll go through the properties next time. Because those, again, mathematics is based on properties, patterns, and procedures. And those are all important. We have to learn how to use these rules. Okay, would you believe if we've already discussed the formula for a circle, you'd never think of it, but we did. What is a circle by definition? That sounds like something you must have gone to a bunch of weddings. It's a thing that has no beginning, no end. If you ever been to a wedding, you always hear the same speech.
Yeah.
A circle is actually an infinite number of points that are all, I'll use the math word, equidistant from a central point. An infinite number of points that are all equidistant from a central point. The words we need are all in the question, or in the definition. What does equidistant mean? Yeah. Same distance. Central point is a center point, is a center. So a circle by definition, if we have a center point, all of these points on this graph are all the same distance away. Right? Now, let's look how that relates to what we've been doing. We have a center point, 0, 0. And if we have a point here, we discussed that by using a right triangle. We found the distance. Same thing. So now, since it has to be the same distance, it creates a right triangle. All right, so I'll put it back over here. So you notice all these points all have the same distance. If I keep on drawing them, eventually I can connect all the points. And that's supposed to be a circle. So what formula do we use to define these triangles? The distance formula, Pythagorean theorem. This is also called the Pythagorean theorem. Theorem. A squared plus b squared equals c squared. Where a was x2 minus x1, and b was y2 minus y1 squared. And c is now the distance. The distance, it has another name in circles. What's it called? What is the length from the center of the circle to the circle? What is that length called in the circle? Radius. So instead of D, we're going to be used, whenever we use R, it's a radius. Let's look at this line here. This is x1, y1. This is x2, y2. But you notice that x1, y1 is the same for all of these points. The center is x1. But since it never moves, it's a fixed number. We'll call it HK. So anywhere we see an x1 and y1, so x, that's H, and that's K. And we don't really need the subscripts anymore since there's no other thing. So the formula for a circle is this. There's your equation of a circle, which I'm simply going to write EOC from now on. And EOL for equation 9. And like last time, how do we get rid of the square? We square root. The difference is subtle. Why we write both of them down? Because if on the right-hand side you see a radical, then whatever's on the left-hand side is the distance. But if there's no square root, this side, the distance is squared. And then we have to square root it to find the distance. So let's look at some examples here. This is so tell me the center and tell me the radius of this equation. Is what?
4.
It's why would it be 4? Because remember, if there's a square root there, then the radius is what the radius is. You're right. If there was no square root, then it would have been 2. But the radius is 4, since there's a square root on that side. Easiest way to do this is write down the equation. Since it has a square root, we're using this one. So the radius is what the radius is. What's my center? Remember my center is HK. 5, 4?
Yeah.
It can't be because they have different signs.
8.
7, 8.
Negative 1?
Look at the equation. H is right after the minus. So if it's a negative sign, it is what it is. But that's a plus. The only way that could turn into a plus is if its K is what?
Positive.
Negative. Because that's already negative there. If k is negative, negative times negative makes it a positive. So it's -4. Basically, it's this. It's always the opposite of what's inside the parentheses. The reason for that is because we're shifting it from the origin. Since it's x minus 5, the answer is 5. Since it's y plus 4, it's -4. It's opposite what's inside there. How about this one? Find me the radius, find me the center. No.
Said it, and I immediately realized.
Because remember, put the formula, this one doesn't have a radical over here, so it's r squared equals x minus h squared, y minus k squared.
So does that mean it would be 25?
You know, because right now, this side here says r squared is equal to 5. What is r? How do we get r by itself? Square root. So r is equal to the square root of 5. So what's h and what's k? So there's a number inside here. So it's the opposite of that. It's going to be what? -3. This one doesn't have a k, so what's k going to be? 0. Because y minus 0 is simply y. Where's the center? Where's radius? Center's at the origin because there's no plus or minus h and k. What's the radius?
So that would be the square root of 1, correct?
Which is what?
1.
The square root of 1 is 1. Yeah, it is.
The center should be -3.
Center should-
-3, yep, it's always opposite signs. And what's the radius?
Square root of
Does not exist. Because remember, a radius can never be negative. The radius is simply always a positive. That's why it's in the formula, it's r squared equals. A squared term can never equal negative. So that's a trick question. I made a mistake writing it, so I decided to keep on going with it. But no, you can never have a negative radius because the radius itself is always, remember, the distance. So we talk about how far is it from here, from Grand Prairie to Dallas? Say 15 miles. How far is it from Grand Prairie to Fort Worth? 15 miles. It's neither positive or negative. Distance is never negative. Everybody okay with circles? Just takes practice. Okay, how about this? Give me the equation of a circle given the center is at -2, 3, and the radius is 4. You always start off writing your formula. Will everybody have the same answer? Probably not, because some students may write this formula down. They're both the same thing, aren't they? Both equations of circles. It's just they're written different. This one has an r squared, the Pythagorean theorem, and this one's r. It's the same equation. They look different. Yes. But typically, to make it same for everybody, I would say which format you should put it in. But I simply ask, just put in a formula equation of a circle. I could also put it here. The radius I could put, since r is 4, if I use this, it's going to be 16. Because this formula, so if 4 is equal to x plus 2, y minus 3, it means the same thing as if I put they're the same thing, because this one has a square root over here, this one doesn't. This one is r squared still. Then it has to be the square root on the other side. Yes. Like the distinction of the formula themselves. If the square root's on this side, r is over here. If there's no square root over here, then it's r squared on this side. Why is it x plus 2?
Well.
2 is negative.
Two's negative, so. you have
So,
to flip it and make it
Yeah, so we
positive.
have x minus a -2, which makes it x plus 2. Again, it's the basic rules of math that has eluded you for the last 12 years. And you didn't think about, and I don't need to know this. I use a calculator and I'll get it done. I am trying to teach you how to use your brains and think through these things. Let's graph a circle, and that'll be the last thing for the day. To graph a circle, you need to know two things. You know the center and the radius. So what is our R? What is our C?
Positive.
Right. -1, positive. It's always the opposite. What's our radius? Yep, because the square root's on this side, that's just R. So once you find the center and the radius, plot the center. So it's at -1, +3. There's a center. From C, plot points are units up, down, left, and right from C. So from that point, my radius is 2, so I go up 2, put a dot there. Go down 2, put a dot there. To the right 2, and to the left 2. Then connect the dots. And there's your graph. This is that simple. Yeah, it looks nicer if you have a compass, but this is good enough for me. Yeah, because what the computer is going to do is you plot the center, you plot one of the points, and just draw the graph. It'll expand it for you. So it'll be the same radius. All right, that's that for section 1.1. What do y'all think? Bring back some memories?
I think that I left high school in 8 gap years and now I'm trying to remember all of it.
Trust me, it'll come back to you.